We want to find k so that f of negative 5 equals 10. So what that means, if I were to plug negative 5 in for all the x's, we want the function, which would be like the y value, to equal 10. Now, sometimes it's easy to just plug in negative 5, okay? But on this one, these numbers get pretty big if you're just plugging it in. So instead of plugging it in, I'm going to do synthetic substitution. Okay, so this tells us our x value. That's like our 0 that we've been using in other problems. So whatever the x value is, you plug that in. Take your coefficients. So I have 2, 8, negative 6k. I'm missing the x term, so I'm going to fill in a 0 there. And then my constant is negative 40. And what I'm going to do is just go through synthetic division all the way until the end. So that's 2, negative 10, negative 2, positive 2. These you can't add together. So that'll just be negative 6k plus 10, or you can write 10 minus 6k. I just like to put the variable first. Then I'm going to multiply by negative 5 and be sure to distribute it to both terms. So that'll be 30k minus 50, and then add it with the 0. It'll just stay the same. Then again, distribute the negative 5 to that. That'll be negative 150k plus 250. Add it with the negative 40. So that'll be plus 210. So remember, our remainder, that's always equal to whatever we would have gotten when we plug in a negative 5 for all the x's. So now I can just take my remainder and set it equal to 10 and solve. So I'm going to subtract 210. That'll give me negative 200. Divide by negative 150. The negatives are going to cancel. I can cancel those zeros and then just reduce it. So divide everything by 5 and you're going to get k equals 4/3. Okay, so if you wanted to plug in a 4/3 right here and figure out what that number is and go through synthetic division, you should end up with 10 as your remainder to check your answer.